Okay, so in this problem, this is kind of cool. First of all, hopefully you still know how to do synthetic division that I taught you. And it's like playing the high-low game. You'll see what I'm talking about. So first of all, notice our P is 9. So the first thing you want to do is take 9 and think of all its factors. 9 is 1 times 9, and also 3 times 3, right? So my factors are either 1, 3, or 9. For the Q, that's the leading coefficient. It's kind of backwards. The only way I can make a 2 is a 1 times a 2. Now, we want the combinations of P over Q. So it's going to be either positive or negative, 9 over 1, or 9 over 2, or 3 over 2, or 3 over 1. Now, see how I'm just doing P over Q, and now I'm going to do plus or minus 1 over 2 and plus or minus 1 over 1. So now what? Well, now we're ready to do synthetic. So I'm going to just take my coefficients 2, 1, negative 19, negative 9, and 9. Now, I would start, obviously, with integers and avoid the halves for now. Let's go ahead and try 1 and negative 1. Let's start with 1 here. And again, at this point, you're just kind of guessing. Unless you're allowed to look at the graph, you're going to have to just guess and check. So I'm going to start with 1. We bring down the 2, right? We times. 1 times 2 is 2. 1 and 2 is 3. We times with the 1. 3 minus 19 is negative 16 times the 1. I get negative 25 times the 1. See how I get a negative 16, right? Okay, so obviously that didn't work because we ended up getting a negative 16 here. Okay, so let's now try negative 1 and see what happens. So remember, 1 gave us negative 16. Let's try negative 1 here. Bring down the 2, negative 1, 1, negative 18. 18 minus 9 is 9. Ooh. Negative 1 times 9 is negative 9, and 9 minus 9 is 0. So now I got a 0. Now here's the thing. I don't know if your teacher taught you, but now that we found a root, I already know negative 1 is 0. Okay, now that I know that negative 1 is 0, all I have to do is just take what I have remaining here. Okay, so let me just make sure that was a 9, right? Hopefully my writing is neat enough that I don't screw myself up. So now, instead of doing the whole polynomial, I'm now just doing 2, negative 1, negative 18, and 9, because that 0 already took care of one of my x's, so to speak. Okay, so now let me just set it up here. So now we're going to go ahead, and we already know that 1 is a root. Now, because the power is 4, there should be 3 more. There should be 3 more, total of 4 roots, right? So what should we try next? Should we try 3? Let's see how 3 works. We bring down the 2. 2 times 3 is 6. 5, 15, negative 3. Oh, I got lucky. Look at that. And sometimes you do. So I know 3 is a root. So far I have 1 and 3. These are 2 of my 4 potential roots. Now again, here's the key thing. Now that we're down to 2 roots, this is a quadratic here. Okay, that's a quadratic. So that means now I'm just going to take that and convert it back to a quadratic and solve it with either the quadratic formula or factoring. So this, in other words, is 2x squared. How do I know it? Because I know I'm down to 2 roots. Plus 5x minus 3. Okay, so now Hopefully my writing is needed. So, what was recording or not recording? Hopefully you caught that. But anyways, I found that 1 was a root. Sorry, I just noticed my video went off. I must have accidentally pressed the wrong button. And 3 is a root. And because I know I have 2 roots left, now I'm just going to take this and convert it back to a quadratic. That's what I was doing. I know it has to be a quadratic because there's 2 roots left. Now, let's see here. If I do the x method, I know 2 times -3 is -6, and I need this 5 in the middle. How about we do 1 times 6, because 6 minus 1 is 5, and 6 times -1 is -6. Aha! So this tells me, therefore, I have x minus 1 and x plus 6. And let's not forget, though, it's a 2x squared, so I have to divide by 2 here, times by 2 there. Hopefully you still remember to do that. So now, I'm going to solve this for 0. I have 2x minus 1 equal to 0. I have x plus 3 equals 0. Don't forget to divide by 2 there, right? 6 divided by 2 is 3. And notice I know -3 is another root. And here, if I solve, I get 2x equal 1, right? Because I'm going to add 1 to both sides. And that means x is 1/2. So therefore, we're supposed to find all of our roots, our zeros. Zeros is another name for roots, or x-intercepts. We found all 4 of them. Look here. We found -3. We found 1/2 is 0.5. We initially found -1 right here, and we found the 3 second, right? And remember, they're literally, this is actually the graph using Desmos. Notice those are the 4 points that crosses our x-axis here. Those are what we call our zeros, or our roots, or our x-intercepts. All 3 names basically mean the same thing, okay? So that's how it's done. So quick replay. What we start out to do is we take our p. Remember, the p is the last number, the constant. We take our q, our leading coefficient. We factor each one of them. Then we combine them with p over q, the ratio p over q. And once we do that, now it's just a guess and check game, right? We started by guessing 1. If you remember, we got -16, so why not try -1, right? And then we realized -1 gave us 0. Now, once we get a 0, just do what's left over with your synthetic, so it saves you a little bit of time, okay? And we were able to get lucky, at least I was. I guessed 3, and I got 3 right. I got another 0. And now I realize I had only 2 roots left, right? So this here had to be a quadratic. So as a quadratic, I factored it. And I was able to solve it. And that is number 1 in a nutshell.